Hey guys, it's Tim from LunaSat again, and in this module, I'll be going over what is RF. Well, RF is short for radio frequency, and it's the most dominant form of wireless communication in the modern world, including cell phones, Wi-Fi, Bluetooth, TV, radio, of course, and broadcast GPS signals. And some other uses include radar, meteorology, navigation, and radio astronomy. So without it, you can see that our way of life would be completely different. Now, what is the radio part of radio frequency? Well, radio waves are a part of the larger electromagnetic spectrum, and they can travel in a vacuum and at the speed of light, meaning that we can use this to communicate between the Earth and the moon. And typically these radio waves will be about 1 foot and from 20 kilohertz to 300 gigahertz. Now, with the electromagnetic spectrum, as you can see, this is what it is. And radio frequency falls on the very left end of the spectrum, with its wavelengths measuring from less than 1 centimeter to more than 100 meters. So yeah, pretty cool, right? Next, we have RF and NASA. And how does NASA use it? Well, on the first US crewed mission, one of the key technologies tested by the Mercury astronauts was the radio communication system used to talk to Earth. Later, NASA sets up a global radio communications array and the Deep Space Network in order to communicate with missions to deep space. And you can learn more about the Deep Space Network if you click on the link on this slide. Now you might be wondering, how does this relate to GLEE and the LunaSat? Well, on the LunaSat, we'll be using RF to communicate with the lander, and we'll be sending our science data to this lander, which will then send the data back to Earth. And it's really our only way of communicating with the LunaSat while it's on the moon. Now, for the components on the LunaSat that are RF related, first we have our SX1272 transceiver, which is long-range, low-power communications, and it communicates on either 3 different types of frequencies, either 915, 920, or 868, but we'll be using 915 because it falls into the ISM radio band. And also with the SX1272 transceiver, it has a high spread spectrum, meaning that it won't have very much interference immunity. Finally, we have the antenna, which is PCB helical, and it's the same antenna used for both transmitting and receiving. And we'll be using LoRa modulation in order to send our data packets, and we'll go over modulation in a couple of modules. And then finally, we communicate with the SX1272 using SPI protocol from the microcontroller.